So here we go. No calculator. We're going to find the sine and the cosine if the tangent equals 3/4 and the sine is positive. That kind of went off the page. So the sine is a positive number. Now, what does the fact that the sine is positive, what does that tell you?
We're in quadrant 1 or 2.
Exactly. That tells us that the sine or y is positive, so we're either in quadrant 1 or 2. But look what else they tell me. They tell me that the tangent is 3/4. Well, that narrows it right down for me, doesn't it? What quadrant do I have to be in if the tangent's 3/4?
Quadrant 1.
Exactly. So the tangent is 3/4. We see these problems a lot in chapter 4. They're all over the place. What do we have to do when we have a situation like this?
The Pythagorean Theorem.
Exactly. So 4 squared plus 3 squared equals c squared. So that's going to turn out to be 5. And I want to find the sine and the cosine. Well, that's easy. The sine is 3/5 and the cosine is 4/5. Easy. In this chapter, we're going to learn other ways to approach those problems, but I still think that's the easiest way. But we'll look at some other stuff too. All right, so B says, find the sine and the tangent if the cosine is 4/5 and the tangent is negative. All right, cosine 4/5, that's a positive number. Where am I if my cosine is a positive number?
In 1 or 4.
Exactly, because cosine is x, and that is quadrant 1 or quadrant 4. But the tangent is negative. So if these are my options, but I know the tangent is negative, where am I?
Quadrant 4.
Exactly. So the cosine is 4/5. So I can do my Pythagorean Theorem. A squared plus b squared equals c squared. So that's going to be -3, and please don't forget the negative. So our sine is -3/5, and our tangent is -3/4. That looks really familiar, doesn't it? We've done those kinds of things, so that's not tricky for us at all. But now this next part. Get out your colored identity sheet that I gave you, which, by the way, you'll be memorizing a part of it at a time, not the whole chunk at once. But get out that colored piece of paper I gave you, because we're going to need it when we start simplifying this. No numbers. No numbers. We're just going to simplify tan times cosine. Now, if you look at your sheet, you've got some things called the quotient identities. You find them? The quotient identities, there's only a couple of them. And what does one of them say about the tangent? Oh, I didn't label them as quotient identities. Oh yeah, I didn't label it. But look at the very first column there. Tangent is sine over cosine. So I'm going to replace tangent with sine over cosine. Oh, wait a minute, that's not sine, that's cosine. I copied it wrong. Tangent cosine is the problem, okay. So the first thing I did was remember, or look on my sheet and notice, that the tangent, another way of writing tangent is sine over cosine, which makes sense to you because we know sine is y and cosine is x, and tangent is y over x. You memorize that on your pink sheet or yellow sheet, whatever color it was. So that makes perfectly good sense that tangent is sine over cosine. Well, when I multiply sine over cosine times cosine, I'm just going to be left with sine. So the directions said simplify, so that's what we did. We simplified by rewriting tangent as sine over cosine.
Is that the final answer?
Yep.
Okay.
What else are you going to do with it? All right, so now we're going to look at this one. Now take a look, again, it's in the first column of stuff there on your sheet, the very first column. Do you see the identity that says 1 plus tangent squared is secant squared? One plus tangent squared is the same as secant squared. So I'm going to replace 1 plus tangent squared with secant squared. And again, this is day one. So you're just kind of relying on me to coach you through this. But as you practice these on your own, you'll start getting more comfortable and familiar with these identities on here. By the way, when I keep calling these identities, that's what they are. We call them identities because they are equations like this. That equation is true no matter what you put in for x, right? That's called an identity. It's true all the time. Something like this is not true all the time. So this would not be an identity. This is an identity. And all of these things on this blue paper, for me it's blue, on your colored paper, those are identities. They're true no matter what you let x be. So no matter what I put in for x, 1 plus tangent squared will be secant squared. Okay? Now, this says secant squared divided by cosecant squared. I'm just going to write it out longhand. Would you agree that that's what that says? Now, what is secant? What is secant? What can I plug in place of secant?
1 plus cotangent squared.
No, that would be secant squared would be,
Oh, sorry, I was
would be
looking
1
for
plus
thing.
tangent squared. But that's not what I mean. Secant is 1 over cosine. I don't want to make the problem bigger, I want to make it smaller. So I just changed secant, I just changed 1 plus tangent squared into secant squared. I don't want to change it back. Secant is the reciprocal of the cosine. So 1 over cosine squared divided by, what's cosecant?
1 over sine.
Yep, and it's squared, so it'd be 1 over sine squared. So secant is the reciprocal of the cosine. You're supposed to already know that. You need to know that for your test. Cosecant is the reciprocal of the sine. So now I got a fraction divided by another fraction. So instead of making that a divided by, I'm going to say 1 over cosine squared times sine squared over 1. Because that's how I divide fractions, right? I multiply by the reciprocal. Well, now I can multiply that. That gives me sine squared over cosine squared. What's that? We've already talked about that today. What's sine over cosine?
Tangent.
Yep, so the answer is tangent squared. So this mess right here, this big complicated fraction, simplified down to tangent squared. Okay, so the next one, we're just simplifying now. We've got sine squared by the way, when we square trigonometric functions, like if we want to take the cosine of 30 and square it, we normally write it like this, so that we don't have to use the parentheses, but that's what this means. We just put the squared after the function, so we don't need to write all these parentheses. We can't write this. Does everybody understand why it couldn't be written that way? That looks like you're squaring the 30, and that's not what we want to do. We want to square the cosine. So to make sure we're only squaring the cosine, we put the 2 on the cosine, but this is what it means. So this means the sine of negative x squared plus the cosine of negative x squared. Well, look on your sheet. Do you see anything that says anything about sine squareds and cosine squareds? Today we're just in the first column, so please just look at the first column. What do you notice about sine squared plus cosine squared?
It equals 1.
Exactly. And it always equals 1. So the answer to this problem is 1. It doesn't matter what's in the parentheses. That's what it means to be an identity. This could be a p. This could be a root 17. It makes no difference. Sine squared plus cosine squared is 1. Always and forever. It's called the fundamental trigonometric identity. You're going to use it over and over and over again. Sine squared plus cosine squared is 1. It comes straight from the Pythagorean Theorem. We don't have hardly any time, so I'm not going to derive all these identities for you, but I'll derive this one. This is a right triangle. You'll agree with the setup. It's true that x squared plus y squared equals r squared. That's the Pythagorean Theorem. Absolutely true. No one's going to argue with that. Now I'm going to divide everything by r squared. So I have x over r squared and y over r squared equal to 1. So I started with the Pythagorean Theorem and then divided everything by r squared. Okay, what's x over r?
Cosine.
Yep, that's cosine. So I have cosine squared. Y over r is sine squared. And there we go. So there's your identity. Cosine squared plus sine squared is 1. And it doesn't make any difference what's in there. Now, they have to be the same. You can't put a P here and a Q here. But as long as they're the same, sine squared plus cosine squared is always going to be 1. Well, shoot, that was easy. All right, let's see. All of the identities are provable like this. I just don't have time to go through and prove them all. If you're really curious, you can look it up because the proofs are all over the place online. All right, so we've done a couple of problems. Does anybody have an idea what we might do here? Well, our job is to simplify it. So what might we think about doing? What's tangent? What's a way of rewriting tangent?
Sine over cosine.
Yep. And how can I rewrite cotangent? Look at your sheet. What does cotangent equal?
Cosine over sine.
Yep. Guys, seriously now, let's engage a little bit. If tangent is sine over cosine, won't cotangent be cosine over sine? Yes, because what's the relationship between tangent and cotangent? They are
Inverses.
yes, reciprocals, right? Multiplicative inverses, reciprocals. Okay. Now let's see, I've got a couple of different options. Obviously, I've got a distributive situation, but I also have two fractions being added. So let's do this. Let's get a common denominator and add our two fractions together. Okay, so we're just going to add these two fractions together. So in order to make the denominator the same, and the denominator will be cosine sine, I'll need to multiply this one by a sine, and this one by a cosine. Okay, I'm just getting a common denominator so that I can add these two fractions together. Now both denominators are cosine sine, so let's see, what do I have in the numerator? What do I have here?
Sine x squared.
So
Or
sine squared. Yep,
squared.
that's right.
Okay.
That's sine squared. That's exactly right. Plus, what do I have here?
Cosine squared x.
Yep. And now your little hearts are just beating out of your chest because what's that?
1.
Yes. So all that junk now has boiled down to 1 over cosine sine. Now you're still multiplying it by the sign that's out front. So remember, when you multiply it straight across, so that's going to be sine over sine cosine. Sine times 1, 1 times sine cosine. Well, what happens now?
Is it 1 over cosine?
It is 1 over cosine. Which, by the way, is what? What's 1 over cosine?
Secant?
Yep. So this big deal right here just boiled all the way down to secant. Let's go back through the steps to make sure we understood every step along the way. First thing we did was change our tangents and cotangents into sines over cosines. We've only done, what, 3 or 4 problems, and we've done that twice already. That's a big deal. When you see a tangent, one thing to think about is change it into sine over cosine. Once I got them changed, then I noticed that I have two fractions to add together. So I did what I do with all fractions. I got a common denominator and I added them. As soon as I did that, this popped up. And it's your first day with this stuff, but you really need to remember that sine squared plus cosine squared is 1 because it comes up a lot. And then we just multiplied and simplified. All right, that was fun. Let's see, one more on this page. All right, this one's got a lot of squaring going on. So on the first column of your sheet, find all of the identities that are squared. They're all grouped together. They're called the Pythagorean identities, and you know I just verified one. That's why they're called Pythagorean. They come from the Pythagorean Theorem. So what do you notice about this? Look at those identities that have all those squares in them in the first column. And what do you notice? Do you notice anything?
Cosine squared plus sine squared equals 1.
The denominator's 1. Yep, the denominator's 1. No question about it, it's 1. Now, I know that the top has V's and the bottom has X's, and that could be problematic in some problems, but not here because this is completely gone now and it just makes 1. So now I just have to worry about the top. Do you have any identities on that paper that have secant squareds and tangent squareds in them?
Yes.
You do, and in fact, we've already used it. The identity that's on the paper says 1 plus tangent squared is secant squared. But if you were to subtract tangent squared from both sides, this is an identity, this is an equation. So I can subtract tangent squared from both sides. Doesn't it say secant squared minus tangent squared is 1? So your denominator was 1, straightforward from your identity, but your numerator is also 1, isn't it? Once we rearrange the identity. All right, we got a couple more. Let's see how this works. See if you can make a go of it. Why don't you look at problem F and write down something in pencil maybe. Write down something that you think you could do to start simplifying this problem. All right, who's going to be brave and shout out an idea? What did you think about doing in terms of having to simplify this?
Make the denominator the same.
You absolutely could do that. I am going to use my experience though, Jacob, and suggest, okay, all right, back up. Do you remember how in geometry, when you had to do your proofs in geometry, and some kids would do the proof in like 5 steps, and it might take you 15 steps, and eventually you get there and it's all okay? So there are zillions of ways we could start this problem, but I might as well share my experience with you. I've looked at a couple of these already today. What is tangent and what is secant? Can I rewrite those? Can I rewrite this in a way that maybe is in terms of sines and cosines? What's secant squared?
1 plus tan squared.
Okay, what else is secant squared? It is, but what else is it?
1 over cosine.
It's 1 over cosine squared. And tangent squared is sine squared over cosine squared.
Yes.
We've changed that one now in half of our problems. Tangent squared is, or tangent is sine over cosine. Now, this is a big ugly fraction. So remember what this means is 1 over cosine squared times cosine squared over sine squared, right? Because when I divide by fractions, I multiply by the reciprocal. Well, what happens here?
The cosines cancel out.
They do. So what am I left with? My 1 over sine squared, which was the original. And now what have I got here?
Just
Another 1 over sine squared. So I have 1 over sine squared, which by the way is cosecant squared, and another cosecant squared. So this mess simplifies to what? One cosecant squared and another cosecant squared makes?
2 cosecant squared.
Yeah. That's exactly right. 2 cosecant squared. So again, I want you to start thinking about, because you're going to have to practice some of these on your own, and we're going to practice more, don't worry. But you start thinking about some of these techniques that I've used. It is generally helpful, unless it's an identity, like cosine squared plus sine squared, or 1 plus tangent squared is secant squared. It's generally helpful to change into sines and cosines, because once you get everything in terms of sines and cosines, then stuff will usually start canceling out, which is exactly what happened here. Okay, this next one, I think I copied it wrong, because well, I don't know. Let's see. I'm not sure what's going to happen here. I think I copied it wrong. There is only one thing that I could do with this problem. And it's kind of sophisticated for our first day, but I'm going to go ahead and do it since I have this problem on the paper. I know that sine squared plus cosine squared is 1. That's fact. So what does cosine squared equal? Sine squared plus cosine squared is 1. So what does just cosine squared equal? Cosine squared equals?
1 minus sine.
Squared, yep.
Yeah.
So I'm going to come up here, and I'm going to see what happens when I take out my cosine squared and replace it with 1 minus sine squared. So again, this identity is all over the place. Got to use it all the time. Notice that wasn't squared, so there's no way to combine these two. This identity requires both of them to be squared. So there was no combining to do. So instead, I said, okay, let's change the cosine squared into 1 minus sine squared. Okay. Now, let me distribute the negatives. So I have sine x minus 1 plus sine squared minus 1. Does that look okay to everybody? Let's clean it up a little bit. I think I'll put it in descending order. So I got my sine squared plus sine minus 2. Now I'm going to give a bonus point to anybody who notices something right now. The first person to notice something. What could I do?
Why does sine x not have a squared above it?
This one does not. This one does. Because when I replaced cosine squared, it was 1 minus sine squared. So then I rearrange my order, put sine squared first, and then this sine next, and then combine the two ones. This was extra. Anybody see anything to do at all?
Could you factor?
Yes! Who said that? Declan?
Mm-hmm.
You're the man! Awesome! You can absolutely factor it, Declan, because it's a quadratic, and anything I can do with a quadratic regular equation, I can do with a trigonometry equation. Now, I don't know if it factors or not, but we're going to give it a shot. What do you think? What might be in the back end of those parentheses if this is going to factor? I need a plus and a minus, right? Plus 2 minus 1. Look, when you FOIL, guys, you get sine squared minus sine plus 2 sine, and then minus 2. Now, it's not an equation. If it were set equal to 0 or something, then we would solve each parentheses, but that's not. It's just a simplified problem, so we're going to stop right there. Okay? Declan, when we take our test, remind me and I'll stick a bonus point on it for you.
Thank you.
No, thank you for making my day. Awesome. Awesome, awesome, awesome. Now, I have no doubt that some of you are feeling overwhelmed right now. You're just going to have to power through it, guys. You'll catch on, but your life is going to be immensely easier the more comfortable you get with these identities. And I would suggest that right now, your focus be on the first block of 5, and then the block of 3 right underneath it. That's what you should have memorized. The block of 5 at the top, and the 3 right under it, the Pythagoreans right under it. Those are the important ones for you right now. And when those become like at the tip of your tongue, you won't be struggling so much. All right, here we go. Now we're going to solve an equation. So we're going to do some of the same stuff, but we're actually going to come out with an answer now. We're not just simplifying, we're going to get an answer. And we're going to do this without a calculator. So there'll be some test review in here too. What's step 1, do you think, when you look at this problem? This is a complicated equation. What do you think might be a good way to start?
Add cosine to the other side.
No, that's a good guess, but that isn't what we want to do. That will not work. Good guess, though. Good attempt.
You could make a line graph. I was just suggesting, or something like a graph because of the 0 and 360.
No, what the 0 and 360 is going to do means is I'm going to be making some triangles here to figure out what angles are the answer. The answer to this question is going to be angles, okay? I need to solve this equation. So I'm going to factor. I'm going to factor out a cosine. And when I factor out a cosine, I will be left with 2 sine minus 1. Now, this one is set equal to 0. So I'm going to take both of my factors and set them equal to 0. These individually could be test questions, you guys. Now, this is not, I mean, that's more than you're going to do on your test tomorrow. But this could be a test question, and this could be a test question. So let's talk about this one. Where is the cosine 0? Now, if cosine is 0, and we're talking about all the way around the circle now. We're going all the way around the circle. If the cosine is 0, that means the adjacent side is 0, or the x is 0. Don't I have to look on my circle? I can't draw a triangle if one of the sides is 0. This is 0 over 1. I can't draw a triangle like that. Does that make sense to everybody? So I need to look at my circle. And I need to go around the circle and find all of the points, because I'm going all the way around according to the directions. All the points where cosine or x is 0. Where does that happen? What are the angles that have a cosine of 0?
Top point and bottom point.
Okay, we're not going to write top point and bottom point in the answer blank. What are we going to write? What angle is that? 90 degrees and 270.
And 2 pi over 3.
No, that would be 3 pi over 2 in radians. It's 270 in degrees. So we're doing degrees. This is a degree problem. So we got 90 degrees and 270 degrees. Those are the answers to this part of the problem. All right, that could be a test question right there. You need to know that if that's a 0, you're looking on the circle. You need to know that cosine is x, so you're looking for where x is 0. This could be a test question all by itself. That right there could be a test question. So what are you going to do with that?
Add the 1.
Yes, thank you. Add the 1 and divide by 2. Now, we're going to look at a triangle here. We're thinking about all the way around. Where could I have a triangle that the sine is positive 1/2? Where could that happen, that the sine was positive 1/2?
The first quadrant.
Okay. Could it happen anywhere else?
Second quadrant.
Indeed. And I don't know what the rest of you were thinking, but the people who knew that remembered that sine is y. And if y is positive, you have to be up here. So you've got angles where the sine is 1/2. Opposite over hypotenuse is 1/2. You need to recognize that triangle and know this angle is how big?
30 degrees.
Yep. And remember, your triangles are always congruent. So once you figure that one's 30, you know that one's 30. So one of your answers is 30. That's this angle right here. It's 30 degrees. The other answer is the angle that goes all the way around to that 30. How big is that red angle that goes all the way into the second quadrant and stops 30 degrees before 180? 150, exactly. So there are the answers to that question. So again, far more complicated in the beginning than you're going to see on this test. But this part you do need to know. This is chapter 4 stuff right here. Does anybody have a question about that before I erase it and we move on to the second one?
So those are going to be the final answer. You don't have to like combine them in any way.
No, x equals. All of these are the answer.
Okay.
So what that means is, I'm erasing the problem right now, but if you took any one of those numbers and put it in for x in the original equation would work out. All of those are possible answers. All right, another one, exactly the same directions, exactly the same style. Having done the one we just did, what do you think is the best way maybe to start this? Maybe best is the wrong word. What is probably the most efficient way to start this problem?
Factor out the tangent.
Exactly. If we have a common factor in an equation, we want to factor it out. So if I pull out the tangent, I'll be left with root 2 cosine minus 1. Don't forget, when you pull out the entire term, You have to put a 1 in for a placeholder, just like you do in regular math. Now what?
Set both of the equations equal to 0.
Exactly. Now we're back to stuff like we really should already have a good handle on. When you see a 0 here, when a tangent equals 0, that would mean that one of the sides of the triangle would have to be 0, right? And that can't happen. So again, we're going to look at our circle, and we're going to go around the circle, and we're going to find all of the places, because we're going all the way around, we're going to find all of the places where y over x is 0 over 1, or 0 over something. Where is y over x going to be 0? Where does that happen? What angles?
0 and 360.
Well, we don't ever, well, I shouldn't say ever, but we don't usually include 360, so 0 would be 1. Certainly right here, the tangent is 0. Where else is the tangent 0?
180.
At 180, absolutely. So the two answers to the first part of the problem are 0 and 180. 360 is also an answer, but since it's the same as 0, we don't include both. All right, so now what do we do?
Add 1 and divide by radical 2.
Exactly. So we have cosine equal 1 over root 2. Now, I wouldn't rationalize that. That is not the answer. That tells me there's an angle out there somewhere that has a cosine of 1 over root 2. Where will that be? Remember, you're going all the way around. So what quadrants will the cosine be a positive 1 over root 2?
1 and 4.
1 and 4. And cosine is adjacent over hypotenuse. So do you recognize you got a 45-degree angle? So it's easier not to rationalize it, so you physically see the 1 and the root 2 in your picture. So your answers are 45 degrees. That's one of them for sure. But then you got to get the one that's all the way around to here. What angle would that green one be? We went all the way around and stopped
315.
here. 315, that's exactly right. Now, kids, especially since we have used some negative angles for some of our stuff, kids will say, well, what about negative 45? Well, remember your domain says you're between 0 and 360. So do you see that negative 45, while it is a legit answer to the problem, we can't use it because it doesn't fit the framework. Whatever answers you put down have to be in this interval. Okay? So negative 45 is another way to name 315. They're coterminal, but it's not acceptable in this problem. All right, anybody have a question about that one before I erase it? Okay, now the next one is exactly the same, except we're doing it in radians. So we're still going once around, but now our answer will be in radians, which doesn't change anything about how we do it. We're going to do everything the same way. So, what do you think about this first one?
factor out tangent after you like subtract it? to the
Very good. So the first thing you want to do is get that 0 and then factor out the tan. Now at this point, I want to talk about what is something that'll be very tempting for you to do. Did anybody think about dividing by tangent? Okay, I get why you would think that, but the cardinal rule of, or I should say one of the main commandments in mathematics is, thou shalt not divide by a variable. We can't ever divide by a variable because it might be 0. So dividing by tangent is not an option, but subtracting and factoring it out is absolutely an option. And again, when I pull that tangent out, it becomes a 1 there. You gotta have a 1 there when you pull off the whole tangent. Okay? All right, what's the next step?
Set them both equal to 0.
So tangent equals 0, and I think we already did that, but I'm going to do it again because that could be a test question. And sine squared minus 1 equals 0. All right, so when you've got this tangent equals 0, or sine equals 0, or cosine equals 0, hopefully you're getting kind of programmed to look at your circle. Because it would be impossible to draw a triangle with a side of 0. This is opposite over adjacent. So opposite would have to be 0. You can't do that. Can't have a triangle with a side of 0. So we got to go to our circle. Then we got to remember that tangent is y over x. So where is it that y over x gives me 0? Here and here, right? Now when I did it in degrees, I said 0 and 180. Now that I'm doing it in radians, I'll have to say 0 and
2 pi. Oh, sorry, not 2 pi.
pi. Pi is
Yeah.
180.
Right.
Pi is 180. So 0 and pi are the answers to this part of the problem. All right. Now, what about this guy? What am I going to do with him?
Subtract the 1.
Well, add it. Yep. So I'll move the 1 over to the other side. And then, since that's a squared, can I just square root both sides? Yeah. Regular algebra works. And, just like before, you have to remember the plus or minus. So that says sine equals plus or minus 1. Now 1 is another special number because sine is opposite over hypotenuse. Would it be possible to have a triangle whose opposite side was 1 and whose hypotenuse was also 1? Is that possible? No, because this has got to be bigger. So that means I got to look at my circle for this one too. Where is y 1 or negative 1? That's basically what this is saying. Where is sine positive 1 or negative 1? Where's that happen?
1.5 pi and 3 2 pi.
Yep, so pi over 2, 1/2 pi, or 3 pi over 2. All right, we're not quite done with this problem, but does anybody have a question so far? Okay, why are we not done with this problem? Well, do you remember when we were doing some problems earlier and we had extraneous roots? Yeah, well, we've got a couple here. And here's why. In the original problem, there was a tangent. And tangents cause me problems because they have asymptotes. I want you to look at these two answers, and I want you to think about if I plugged pi over 2 into my problem to check it, and I had to find the tangent of pi over 2, what would happen? What is the tangent of pi over 2? What's the tangent right here? Y over x?
Undefined.
Yeah, these two are extraneous. The only answers to the problem are 0 and pi. I know what you're thinking. It's been overwhelming. This is hard stuff, and it's going to get harder, unfortunately, until you get the hang of it. When do you have to worry about extraneous roots? Well, you never have to worry about them with sine and cosine, because sine and cosine don't have asymptotes. Agreed? Okay, so we don't have to worry about being undefined. So sine and cosine, we're in the clear. When your problem has any of the other functions, you want to make sure that if your answers are these quadrantal deals, these guys, you want to make sure that whatever those functions are, they're not undefined at at those points. Okay? So tangent is okay here because it's not undefined. But tangent is not okay here because it is undefined. So we always kind of have to keep that in the back of our minds. All right? And you're going to keep that in the back of your minds until we do this again, which is after our test. So hang on, don't panic, please don't panic, you're gonna get it, it's gonna come to you, it is gonna take some work, and it is gonna take some memorization. All right, which is just your time, and if it's important, you'll get it done. All right? But no panic, you know what's on the test, we reviewed and reviewed, you can review some more, you'll be ready for that, whatever day that is. All right, everybody okay? All right, well, you've done a good job today. We've crammed in a lot of stuff. Try not to be overwhelmed and don't panic. All right? You'll get it. Okay? I'll see ya. Have a good day.
Thank you.
Bye.
Thank you.
You're welcome.
Miss Ford.
Yes.
So for tomorrow, do you want me to come to your room at 8:30?
Yes.
Okay.
Okay?
Thank you. Have a good day.
Mm-hmm.
Miss Ford?
Yes.
Yeah, I got a concussion on Wednesday.
I heard that.
Yeah. So, what did I miss exactly? Did I just miss review?
Yes, it's all videoed. You'll have to get on and get the video. Watch the video.
Okay.
Are you
Do you
allowed
still
to?
want me?
Are you allowed to watch the video? Sometimes they don't let.
No, I'm not really supposed to be on my iPad too much, but I can probably get in the video.
Okay, well that's up to you, and we'll take whatever tests whenever you're ready to take them. All right.
Thanks so much.
You need to come to class and get as much material as you can because it's going to be overwhelming if you don't. Okay.
Yeah, I'll be back on Tuesday.
Okay.
But-
All right. All right.
Thank
Take
you.
care. Bye bye.